What's going on, everybody? Welcome to a new tutorial, which is also kind of part one in a little mini series, but really all we're going to be doing in this tutorial is doing and kind of working through a couple of sentiment analysis libraries that are just kind of out of the box libraries you can download and perform sentiment analysis with. We're going to kind of check them both out, see what they have to offer us, and see which one we want to go with. If there's some other sentiment analysis library you're curious about testing, you can go through the same exact methodology to analyze them and see what you think. So the two that we're going to use are TextBlob and VADER Sentiment. You can just pip install TextBlob, VADER Sentiment. TextBlob is a natural language processing library built on top of NLTK. Whereas VADER Sentiment, so basically TextBlob can do more than just sentiment analysis. And then VADER Sentiment, it's just sentiment analysis. If you're curious about both of these, you can learn more about them if you go to the description. I linked to the text-based tutorial there, and you can check them out here and here. So what I want to do is just get to working with them and test them against known data. So the known data I'm going to use is these like movie reviews, and I've got a positive and a negative file. If I recall to do it, I'll put just straight links to them in the description. Otherwise, just go to the text-based version and find them and download them. Or you can use your own data if you have your own. But anyways, these are just like short movie reviews. So you can just right-click, download, save as these reviews, and we're going to use them for classification. So the first thing I'm going to do is I'm just going to go ahead and drag those over. Cool. And now we can test both of these using this. And I like this data set because they're kind of challenging. They're not necessarily always clear. Some of them are very sarcastic. Some of them are like just plain confusing. Like I couldn't have classified them. So it's a nice confusing set, a real challenge to feed to a classifier. So it's still interesting to see how well can it do, and not just how well can it do on like the whole set, but is it good at filtering out the things that it doesn't know. So there, with a lot of classifiers, a benefit that you can have sometimes is that the classifier itself can determine what its kind of confidence level is when it makes a classification. So if you can do that, it would be nice to be able to go through these two files here, and on the really challenging ones that is it good at least recognizing I don't know the answer, but I'll make a guess, kind of stuff like that. So anyways, we're going to see what we can find with both of these. So the first one I'm going to start with is going to be TextBlob. So we've already got TextBlob imported, and I'm just going to say the analysis equals TextBlob, and all you do is you're just going to pass a string to this. So I'm just going to say TextBlob sure looks like it has some interesting features, and that's it. So what that's going to do is just convert this into a TextBlob object, and we can do all kinds of things with the TextBlob object. So one thing we can do to figure out all the things we can do is just dir it, and let me just make some more space here. Let's zoom out. So obviously we have all the little dunders here, but we can also see all kinds of stuff like polarity and sentiment, which we're interested in. We can see, we can tokenize it. We can do word counts. We can even translate it, part of speech, all that kind of stuff. So there's definitely a lot of things that we have at our disposal. So one thing I thought that was pretty cool is the translation. So one option we have is just to print analysis.translate, and then you put the language code in here. So 2 equals, and let's do Spanish, so ES, and we'll run that. And here you go. This has been translated to Spanish. I'm not going to read that out, but that's pretty cool. I don't know how great of a translation is. Spanish isn't exactly a language of mine. I can sort of speak it, but yeah, so it looks about right. It seems like a pretty dirty translation, but anyways, that's kind of cool that you can do stuff like that. So it's more than just sentiment that we can do. But the other thing we can do, for example, would be part of speech tags. So we can just do analysis.tags. And in fact, let me just get rid of the dir there. We can run that, and then we get all these tags. And just going from the text-based version of this tutorial, I'll just bring it over. But I have all the tags in the text-based version of the tutorial, so check that out if you want to know all of the tags, because there's quite a few. One reason you'd want to know this is for things like if you want to build noun phrases, but also if you want to know what's being talked about here, look for the proper nouns, basically. So in this case, TextBlob is being determined to be that proper noun. And then you can find the other nouns too, and then say, okay, there's, let's say if this was positive sentiment, we could relatively well determine that there's positive sentiment for TextBlob, but why TextBlob? Well, because of the features. They're interesting features, right? So you can start to do a lot of really cool analysis. But anyway, this is for sentiment. So let's go ahead and just do analysis.sentiment. And let's run that. And we see we get two scores. We have polarity and subjectivity. So I want to make sure I'm right on this, but the polarity, I believe, is -1 to +1. So -1 being, negative sentiment, +1 being positive sentiment. And then subjectivity is a degree from 0 to 1, where 0 is very objective and then 1 is very subjective. I'm not finding here. I'm pretty sure that's about correct though. So now what I want us to go ahead and do is we can test these things. So the code that I've written to do that is very simple code. So I'm actually just going to copy it from the text-based tutorial. I don't really see any value of us writing this out. I'll just kind of explain it. So from that sentiment, when we say analysis.sentiment, we see it produces this value, and then we can access these two attributes just using dot notation, basically. So we're saying dot polarity to reference this number. That's that sentiment number. Okay, and then all we're doing is we're just opening these files, reading through, and then if the polarity is above 0, we're saying, okay, that should be positive. If we got that right, add 1 to correct, because this is the positive file, so everything should be positive here. Otherwise, even if we got it wrong, we just pause count +=1, and then we're going to do this one, and then here we just calculate the percentage accuracy. So let's go ahead and run that real quick. Wait for it. Should be relatively quick. There we go. Okay, so in this case, I got a positive accuracy as 71%, which is not horrible. But then the negative accuracy is 55%, which it's above average, but on a sample size this small, we can't actually make that determination yet, probably. But also, even if it was a solid 55, that's a little too close to random for my tastes. So what are some things that we could do? Well, we could start to try to play with, where's the line for neutral, like a neutral zone. So rather than saying is above 0, what if we said it needs to be above 0.2, right? Or below 0.2. Like, it looks like maybe we're too weighted towards the positive. So you could start to play with stuff like that to try to get them both to be relatively equal. But as we can see, even with that tiny tweak, now it's heavily weighted towards negative. So then, you could continue tweaking it. But we're clearly not really seemingly making any gains here by raising that bar. So in this case, 60 and 68. Really, neither of those and nowhere in between those would be a number I would be happy about doing sentiment analysis with to any serious degree. So the next thing that we could do is we could take subjectivity into account. So let's return this back to 0. And then we could ask the question about subjectivity. So I'm just going to copy and paste this line in. And I'm going to say, right, if the subjectivity, it needs to be less than 0.3. So we want to be close to objectivity, right? So that's what we're going to do. And then we're just kind of throw out the other ones. Just to see, is there a way that we could gather sentiment, at least on things that we know we're correct on? So let's go ahead and run that one and see what we get. So it looks like negative accuracy goes up significantly, although our sample size has been seriously, diminished, like almost like a fifth. And then the other option we could do is raise it. Like, what if let's see if we can get more subjective, which to me would seem to suggest that would be more dangerous, right? The more subjective it is, the less accurate we could possibly be. So we do get at least more samples. or I'm sorry, whoops. What I meant to do is say, let's say it needs to be greater than 0.8. That's why we got more samples. Okay, running it again. Wait for it. Okay, so this time we did kind of better, I guess, which is odd. Like, clearly it looks like we don't want to necessarily be too close to subjective or too close to objective. I don't really know. I'm having a hard time understanding how we're supposed to value subjectivity. Either way, though, we're simply not getting enough samples, so I don't see how this is going to be of any use. So at least so far, in my opinion, it's getting kind of challenging to give any sort of real value to here. So the next thing, after we've run through TextBlob, why not run VADER Sentiment instead? So with VADER Sentiment, we're going to build this relatively similarly. Let me see if I can just take it. So with VADER Sentiment, we do have like a little analysis var. Otherwise, most of this stays the same, but I'm still going to just copy and paste it. Paste, and we don't need this twice. So here we just define our analyzer, right? And then to do sentiment, because we're kind of skipping the little phrase of our own, but basically to do sentiment, to do basic sentiment with VADER Sentiment, it would be something like this. I'll just copy it over, right? So VS equals analyzer dot polarity scores. VADER Sentiment looks interesting. I have high hopes. And then we could print out that sentiment. So let me go ahead and do that just so you understand what to expect from this package. So when we run this, what we get is we get negative sentiment, neutral sentiment, and positive sentiment. And then we have this sort of compound score. Now, if we read, which one's the VADER? Yeah, here we go. If we read VADER Sentiment, it should somewhere on here tell us what each of these. Here we go. So, positive sentiment is just where the let's see. So about the scoring, basically what they're saying here is the compound score is your most useful metric if you just wanted a single metric to measure sentiment. But obviously we have quite a few other things. So like, for example, the compound score is a combination of these things, but it might be useful because in this case, this looks pretty clear, right? We only have positive and neutral sentiment. There's really no negative sentiment muddying up the waters. So we could probably be more confident in this compound sentiment, right? So even though we could use compound, and we'll test compound, it looks like we have a few more things at our disposal that can kind of help us detect when something isn't quite right. So anyway, let me go ahead and clear this out. Analyzer, sentiment, analyzer, VADER Sentiment. Cool. Okay, I think we're all set. Let me just get rid of this down here. And so this is the code I wrote for doing VADER Sentiment. So basically it's going to be exactly the same as what we've been working with TextBlob. So we're just asking with VS compound, which is what they said is the good single metric to work with. If it's greater than 0, congratulations, you got positive right. If it's less than or equal to 0, then that's a negative, and so on. So now let's go ahead and run this script. And we get something a little less strangely weighted towards one way or the other, but still not really acceptable. Not something that I would want to personally go off of. So 69 and 57 is just not that great. But if we check the documentation here, it basically says, you really should say anything between negative 0.5 and positive 0.5. We should call that neutral. And then if the positive sentiment, positive sentiment would be above 0.5 and the negative sentiment would be less than negative 0.5. So let's go ahead and try that out. Again, I've already written it out, but it would be some simple changes anyways, but it'll be quicker for me just to copy paste. Let me get rid of this double import. And now, and in fact, I'm going to go ahead and just comment out the library that we're not using. That seems to make sense. So what I've done here is I've built a threshold variable. And then basically what we're going to ask is if the compound is greater than or equal to our threshold requirement, or is less than or equal to the negative of the threshold requirement, then we're going to use it. Otherwise, if it doesn't meet that threshold, we don't care about it. We're going to toss that data out. So let's go. Oh no, what have I done? I just wanted to run that. I think it ran. I don't know, it like copied it over. Let me just run it one more time. Cool. So in this case, we get 87% accuracy for positive and then 50% for negative. Now, that's pretty good, but what if we have another requirement, or just simply a requirement, that we don't want any positive or negative sentiments? So this was basically this was the suggestion of VADER sentiment. It was, hey, use, negative 0.5 to positive 0.5 as kind of your threshold. And honestly, this is about, 50% on negative is horrible. And also we chopped away tons of our samples. So that's not good. So now what I want to try is, what if we just ignore compound and instead we work with requiring the, basically the positive, let's say for negative sentiment, we want to have more negative than positive, but then we also don't want much positive, if any. So what I'm going to do is I'm going to copy over a script that does basically that. Again, all this is in the text-based version. I'm just kind of running through the methodology I use to go through these two. So paste that one in. So basically what we're going to do here is, if the negative findings are not more than 0.1, okay, and then if the positive minus the negative is still greater than 0, or greater than or equal to 0, we're going to say positive is correct. And then we're going to come down here with negative, and we're going to say, okay, if the positive is not greater than 0.1 and positive minus negative is not less than or equal to 0, then we're going to say the negative is correct as well. So let's go ahead and run that one. And we can see we've done much, much better. Now, one problem I see with this immediately is both of these, like in theory, you might have things that are both being classified as positive and negative because we're using the equals. So let me just test this real quick, because I didn't really think about that as I was going through it. So that we can see there makes a massive difference if you're still allowing for that less than or equal to. So we can flip the other one around, but I'm going to be relatively confident we're going to see the exact same issue here. Luckily, this isn't where, oh, that's actually not. So at least in this case, we can go with greater than 0 for the positive requirement, or less than or equal to 0 for the negative requirement. Okay, good enough. I'll have to update the tutorial to reflect that one. But you wouldn't want to continue making making those mistakes. Now, once we're willing to do this, one thing that we didn't give TextBlob the ability to be tested against, 0. Like so we didn't give TextBlob. All we did was test TextBlob with a moving center point, but never a neutral zone. So the next thing I want to do is go ahead and let's test TextBlob in a neutral zone. So let me copy this, paste this in. So now we're going to test TextBlob. The polarity needs to be greater than or equal to 0.5, or down here, we could be less than or equal to negative 0.5, but in the polarity requirement, 1 is greater than 0, 1 is less than or equal to 0. So we've got no overlap going on there like we had temporarily in the other one. Let's go ahead and run that one. Okay, so in this one, we have 100% accuracy. Interestingly enough, though, not many samples. So what if we lower the threshold requirement? So let's just do like 0.2, for example. Let's run that one. Okay, so now we got many, many more samples, but still we're losing quite a few samples. So let me try one more. We'll just go to 0.1. See how many more we gain here. So we gained quite a few, especially in the positive. Negative is still chopping away quite a few, but let's try this. Those aren't even. There we go. Run it one more time. Okay, still 100% accuracy. So interestingly enough, in this one, the real kicker is the stupid 0. Like, it looks like we classify with TextBlob at least a lot of things as zero sentiment polarity. Which is causing a lot of problems, and that's why that less than or equal to was making such a big difference when we moved it around, especially for TextBlob. Less so for VADER Sentiment, it appeared, but why that made such a massive difference here. But as you can see with these rules, we're doing pretty well, and clearly it was because of zeros. So that's basically the two sentiment analysis libraries compared. It looks to me like TextBlob is slightly better, but the other thing I didn't really talk about is the speed. So TextBlob right now is taking me about 6.7 seconds to run through these two files, which is a little over 10,000 samples in total. Yeah, so a solid 6.7 seconds. And let me find a decent version of... let's do this one of the VADER Sentiment. Copy, paste, and we'll run the VADER Sentiment example. This one runs in 3.3 seconds. Now, this one, don't forget though, is the one where we have to be careful with the less than or equal to 0. We don't want to have any overlap, so that's a little more fair of an assessment. Now, we could also, we can probably continue tweaking this one as well, and we might find the same story with either one. I think that probably TextBlob is slightly more accurate, but VADER Sentiment seems to go, twice the speed. So it's really just going to kind of depend on what your needs are. But it looks to me like as long as we're avoiding that 0 mark and properly classifying that or having a neutral classification, it looks like TextBlob is superior. Also, I'm kind of interested in TextBlob just for doing other things besides just doing sentiment. Maybe you want to do part-of-speech classification or whatever. But I'm planning to use this with inputting into a database. So that's why I haven't really decided which one I want to use for this. And honestly, they're very interchangeable, as you've seen. We just need to figure out what rules we want to go off of to make our classifications. But anyways, that is all for now. If you have questions, comments, concerns, whatever, you can feel free to leave them below. Otherwise, I'll see you in the next tutorial.